this YouTube channel, I teach new mathematics alternative methods. I don't teach mathematics using the old methods or traditional methods. This channel is so much emphasizing on the innovations in mathematics. Now, due to popular demand, some people have texted me, have written to me, have called me. They are trying to find out whether my methods can also solve problems of data that has no range. Can my methods or formulas solve problems in statistics on calculating the mean, variance, standard deviation for data that has no interval or range? The answer is true. As long as the data that is given has a constant difference. For instance, the data could be 2, 4, 6, 8, 10. The data could be 3, 6, we have, that is 3, 6, 9, we have 12, we have 15. As long as there is a constant difference, my methods or formulas, they solve accurately such types of problems. So it's not just about statistical problems that has an interval or range, but also this type of statistical problem. I'm failing to state whether it is grouped or ungrouped because there has been a lot of problem and I don't want this debate to start from here. I would like a debate that would point out the weakness in my methods and not to discuss which type of data is grouped or ungrouped. There has been a misunderstanding on that one. So in short, my method also solves problems that has of data that has no interval or range, but as long as the data of those terms that is given, they have a constant difference. Let us quickly look at how we can handle this. And before that, there was also another query, which I'm going to explain here. If the data that is given, the number of terms is odd. Last time, the number of terms were even. So watch carefully how we can handle this type of a problem using Musonda's method. So as usual, we start subtracting first the data. 7 minus 1, that gives us a 6. Then 6 divided by 2, we have a 3. We have a 3. You share that equal to the terms that you subtracted. Then we go in 6 minus 2, that is a 4 divided by 2. We have a 2, we have a 2. 5 minus 3, that is a 2. Divide that by 2, you have a 1, you have a 1. Now we have a 10 without its partner to subtract with. So in that case, you subtract that 10 by itself. 4 minus 4, that gives us a 0. We go to the column for frequency. 1 minus 0, 1 divided by 2, 0.5. Here, we also share that 0.5 here. Then next 2 minus 3, that is negative 1 divided by 2, negative 0.5, negative 0.5. Then 6 minus 3, that is positive 3 divided by 2, we have 1.5. Also here we have 1.5. Now the middle one here, subtract that by itself. That is 5 minus 5, that gives us a 0 here. Then the next column, we multiply dx and df. 3 times that gives us 1.5. 3 times that, negative 1. Then I have 1 times this, 1.5. Then 0 times 0, I have 0. 1 times this, I have 1.5. Then 2 times this, I have negative 1. And 3 times that, I have 1.5. This should be added in the same manner that we add the frequency. This should be also added. So 1.5 plus this, that gives us positive 0.5 plus this, that is a 2. Meaning the other side, it is a 2. We are going to have a 4. Like I've always said, this formula is quite easier. I've found it to be so easier than any other traditional method. It is so easier to the end in the sense that the third, fourth, and fifth column creates a reflection. If I can bring this one here, you will see that there is a reflection between what we have the terms here. I have 1, 1, I have 2, 2, I have 3, 3. So let us just fill up here, and the other side we know it's a reflection. The same way in the other side, we have 1.5 reflected here, this reflected there, this this reflected there, this reflected there, this reflected there. Then in the last column, that is, we'll be multiplying frequency times this one squared. So 0 times 3 squared, it's a 0. 3 times 2 squared, that is 2 squared is a 4. 4 times 3, that is a 12. Then I have 1 squared, that's 1 times 3, I have a 3. Then 0 squared times 5, I have a 0. 1 squared times 6, I have a 6. Then 2 squared times 2, I have 8. Then 3 squared times 1, I have a 9. Now I have to add 2 plus 3, 15, 15 plus 6, 21, 21 plus 8, that is 29, plus 9, that gives us 38. That is the summation of FG x squared. So now, first question, we are calculating the mean. And the formula that I invented, I created for calculating the mean. So mean is equal to A plus the summation of dx df divided by summation of that. Now what is A? A is the median value of the terms that we are given here of the data. So we have 1, 2, 3, 4, 5, 6, 7. To find the median value, just add the last one plus the first one divided by 2. However, here we can just go in the middle because we have 7 terms here, so the middle one is 4. Or you add 1 plus 7, it's 8 divided by 2, you get a 4. So our A is simply found by adding 1 plus 7 divided by 2 plus. This I also call it statistical factor, a very important factor. And you are yet to see more things about the importance of this and how it can be used to identify the median of such type of data. So this we have is 4, we divide by, we have the summation of frequency which is 20. So this is 8 divided by 2 plus 4 divided by this, that gives us a 0.2. Then this gives me 4 plus 0.2. And the result is, I can write it down here, 4 plus that gives me 4.2. So 4.2 is the mean of this data that we have here, which can be verified using other traditional methods. And the answer will be accurately, exactly like that, with no absolute error. Let's look at D, how we can find the standard deviation. So standard deviation is equal to the square root of summation of fg squared x divided by this minus, we square the summation of the statistical factor so this will be equal to, this is 38 divided by 20 minus this one, we in fact found that is 4 over 20, this one, 38 divided by 2, that gives us 1.9, 38 divided by 20, that gives us 1.9, so 1.9 minus, the other one is 0.2 squared, which is 0.04. When we do the subtraction here, we get 1.86, which gives us a result of the square root of 1.86, that is 1.36. Thank you very much, and to all those people who are appreciating what I'm doing. It's an encouragement, and that motivates me to work even harder to bring new things in mathematics.